Well, the last part is multi-group analysis when the data is not normal. So whenever your data is not normal, how can you deal with that type of data and how would you analyze that type of data? So first you need to understand the case. Crystal Valley's H test is used to compare more than two groups on the basis of their medians when the assumption of normality is violated. So whenever the assumption of normality is violated, in case of multi-group analysis, you need to analyze your data for mean comparison using Crystal Valley's H test. So what is Crystal Valley's H test? Crystal Valley's H test is a non-parametric test used to determine whether there are statistically significant differences among the medians of three or more independent groups. Remember one thing, when you are dealing with the uh, normal data, you are basically comparing the means of your different groups. But when you are dealing with the not normal data, you are actually considering the median as an average value in order to compare them between different groups. So it is an extension of the man Whitney U test for two independent groups to situation with more than two groups. The Crystal Valleys test is appropriate when the assumption for parametric analysis of variance are not met, such as when the data is not normally distributed or when the variances are not homogeneous. So, what we will do, what are the assumptions of Crystal Valleys H test? So here comes the first assumption of Crystal Values is independence, which means that the value of one group should be independent from others group. There should be random sampling for data collection. There should be ordinal or interval data. There should be homogeneity of variances. It may be or may not be available. The Crystal Valleys test is less sensitive to unequal variances compared to parametric. In case of parametric test, uh, the ANOVA is more sensitive towards equality of variances. But in case of Crystal Valleys, there is no issue. There is no sensitivity of unequal variances. So you don't need to be worried about equality of variances if you are using Crystal Valleys test. So mutual independence of observation, the Crystal Valleys test assumes that observations are independent not only within groups but also across groups. So here comes the example number 6. A health scientist wishes to compare the survival experiences after breast cancer with different pathological tumor size. Sometimes a lot of women has to face a tumor as a breast cancer in their chest, and how the scientists wish to compare the different tumor size with their survival experience. So you are required to determine whether or not the median survival time of the patient is significantly differ in different pathological tumor size. So you are basically comparing the survival time. So if a person has, if a female has some tumor in her chest, with reference to its size, we may analyze the survival time with tumor size. So is there any difference between the size of between the size of tumors and between survival times of these females? So what we do, uh, I will analyze the procedure uh, here. You have example number 6 data. I will open up. So you have the data set like this as an example number 6. Here you can see the tumor size. One indicates the tumor size less than 2 centimeter. 2 indicates the tumor size between 2 to 5 centimeter, and 3 indicates the tumor size greater than 5 centimeter, while the 0 indicates the tumor size of 0 centimeter. So here are the four categories of tumor sizes. So you need to compare the size of the tumor with the survival time. If a person has tumor, so how many years he or she can survive. So first thing you need to analyze the non-parametric test in order to check the normality of the data. So survival time is basically the continuous variable over here. You need to click OK, and you will find here asymptotic sig value is less than 0.05. It means the data is not normal. So what will you do next? How will you analyze it? You go to analyze non-parametric legacy dialog box, and here you have k independent samples. If you have two independent samples, you will select it. But if you have more than two independent samples and they are non-parametric, you will select k independent samples. Just click it, and you need to put your continuous variable and test variable list, and you need to put your tumor size group variable into the grouping variable. You need to define the range. It is asking about minimum and maximum range, as we know that we were indicating 0 for 0 tumor size, and we were indicating I think 3 for the maximum tumor size. If we want to verify it, you can go to your data set and you need to check it. You have minimum value of 0 and you have maximum value of 3. So always remember that the values you are seeing over here must be the same that you are putting in your analysis. So I will go again uh, to my non-parametric analysis, legacy dialog box, k-independent sample, and I will define the range. Minimum was 0 and maximum was 3 over there. And I need to click the continue. And here you can see the test type that critical values H was already selected. So you need to keep it selected and click OK. And you will see the results like this. You can see uh, the asymptotic sig value is less than 0.05. It means there is a significant difference between the tumor size, between the time span or expectancy with reference to tumor size. So there is a significant difference between time and tumor size. Uh, if we would like to individually interpret these data, we can say that 826 females having a tumor size of 2 centimeters with an average value of 576.17 as a mean rank, while 283 females having a tumor size between 2 to 5 centimeter with a mean value of 522.13, and 12 females having a tumor size greater than 5 centimeters showing an average value of 433.46. So what we can conclude here? We can conclude that majority of female, because 826 was the figure, majority of the females having majority of the females, or 826 females having a tumor size of less than 2 centimeters, have more life expectancy. It means if the size of the tumor is small, you may have more life, because this mean value is related to the time spans or months. So we can consider that if a lady has a tumor size which is less than 2 centimeter, she may have a longer life as compared to a lady with 2 to 5 centimeter tumor, and the less life expectancy is with a lady with 5 centimeter or greater tumor. So there are 12 females who may have lesser life period as compared to others. So this is the way you can interpret this data, and you can also comment on the overall significance difference, because the asymptotic sig value is less than 0.05. So we can say there is a significance difference between the tumor size differences along with life expectancy of different groups. This is basically the topic was complete, and you need to complete basically the example number 7 drill. And this was the last topic of our basic level of SPSS, and I hope you enjoyed a lot. You have learned a lot. Basically, this was the topic that previously I have planned to present to you, or to give a session on it on Saturday. But tomorrow, basically, my daughter has a birthday, and my family requested me to spare one day for her. So that's why I have planned that I will complete the two group analysis today, and we will have a off session. We may have a session off tomorrow. Basically, there will be no session tomorrow, and we will have our next session on Sunday, and we will proceed with next topic, which is basically the intermediate level of SPSS. And after completing the intermediate level, we will move forward to the most advanced form of SPSS, like EFA, like discriminant analysis, and so on. So this was all about today's discussion. I am again confirming tomorrow we will have no session tomorrow, because we need I need to celebrate the birthday of my daughter tomorrow. So we will have next session on Sunday. So if you have any question, you may ask, and you will do example number 7 drill after completing this session. So if you have any question up till this discussion, you may ask, please.